So we make first just a brief introduction, and then we will have a few demos just to give you a better idea of the functionalities that we can execute in this environment and what we can do. Yeah, so as a start, TVB Cloud, we basically have created several components, software components that we have integrated and deployed in an infrastructure. This infrastructure that is called the virtual research environment that is located in Charité. So it's a cloud infrastructure with different servers and components for security, for executing applications, virtual machines. And on the right, what we see is architecture component or architecture diagram of these components together. We will see this more in detail in the next part. But just to give you an idea, basically the main components of this of the whole TVB Cloud is a web portal from where we can access, we get the first access to all these services. It's you need a user and a password to enter into this environment and get access to the different services for secure data ingestion, so to load data and to then have resources for running pre-processing pipelines. We also have a knowledge graph, and we have adopted some standards for data sharing within this context. Command line workflows to execute different parameters and different functions to process the data that we upload into this portal. The deployment of brain simulation software to run the different simulations in using the resources that are provided in this infrastructure. Graphical user interface for data visualization and exploration. So that also poses different requirements in the infrastructure. And we are integrating different services for semantic searches, like Petra mentioned, for databases that collects, that perform data mining and gets information about mechanisms that are used in brain simulations, and the integration with high-performance computing. Yeah, so this is, in general, all the components that we offer in this infrastructure. So now Patrick Bay will talk about the VRE portal, containerized pipelines, and knowledge graph.
Yes, thank you, Pedro. I would give a quick overview of a typical neuroimaging use case within the VRE. And for that, we're going to follow along the diagram that Pedro already showed to take a little bit of a closer look at the different steps and how they're integrated within the VRE. So where we're starting with our use case project is data that we have available, a test subject, as well as corresponding annotated metadata, both, as I already said, following certain standards in formatting, open lines, as well as bits. And we have already developed containerized processing pipelines that we want to apply. A container here is a way of easily creating self-contained processing software that can easily be shared and enhanced reproducibility. So the first point of contact is the VRE portal in step 1, where we upload our data set and our containers into our already defined project. And where we land is within our user-specific green room. That is, as Petra mentioned, a specifically access-restricted area where we can upload medical data and, if necessary, perform additional steps of pseudonymization. So the way we want to do this in this use case, in step 2, is we make our data available for the workbench tools that we are using, in this case, a virtual machine, where we retrieve the data from the green room storage using the deployed VRE command line interface tool. In step 3, we're doing this here manually because we want to validate our processing steps on a case-by-case basis. This is obviously can easily be automated, but for our use case, we want to do this step by step. So we are retrieving our data in step 3 and then run our first containerized defacing pipeline that we retrieved as well from the portal after the upload. If that step 4, the containerized defacing pipeline, is finished, we can use the graphical interface of that workbench tool, of that virtual machine, to validate the results and see if the defacing, so the removal of parts of the neuroimage volume that might identify a patient, if that is sufficient enough. If that is the case, we can in step 5 upload the data back into the green room storage, again using the command line interface tool. So after this procedure, the data is again available inside the portal. And in step 6, in the portal, the project administrator, for example, the PI, can approve the data to be copied from the green room into the core zone, where now we have access restrictions to all VRE users that have been specifically assigned to our Lesion to TVB project. With the data available in the core zone, we can, in step 7, use the workbench tools specific to our core zone by again retrieving the data using the command line interface tool, and already enable additional features such as, for example, provenance tracking using the integrated data lab that we have available as well. So the now defaced data set that we validated and have available in our workbench tool can be used for additional processing steps in step 9, again using containers. Even computationally expensive processing step can be performed here by harnessing the power of the Charité high-performance computing environment that is seamlessly integrated into the VRE. And as Petra already mentioned, lives inside the same Charité firewall space, so our data stays in a protected environment. If that processing is performed and we are happy with our results and end up with a TVB-ready data set, we can, in step 11, again use the command line tool, because in our case we are doing this manually and not automated, use it to push our data back into the core storage and make it available for further processing or analysis, for example, in brain simulation using the virtual brain. Additionally to the processed neuroimaging data, we already uploaded in the beginning, we uploaded correspondence annotations and the metadata that we can here in step 12 integrate into our knowledge graph in the VRE that is implemented using the Blue-Brain Nexus in a way that now makes our data available to researchers to query the data and to visualize links within either our data set specifically and different versions of that, or across data sets available in the VRE, looking for specific terms and parameters of the metadata, such as patient disease states, modality, etc. And to get a little bit of an example of how those steps look, so you're going to see in the next part a short demonstration of how these steps look using the VRE portal itself. So we're first logging into on that landing page that Petra already showed, logging in with our Charité credentials, and already see our Lesion to TVB project that has been provided. We're uploading our data, as we said, in the folder here is the bits lesion data to our subject that we want to process, as well as the OpenMinds formatted annotation metadata. Using this OpenMinds data and having it integrated into the knowledge graph that is in the VRE, we can use it to investigate and search our metadata for, like I said, for example, for the dataset version that is stored using linked JSON files. But we can also look at the visual representation and zoom in and click at different links where we see that, for example, funding institutions, license, the author of the dataset version, modalities, etc., can be linked between datasets and within the dataset that the researcher provided. Going back to the actual neuroimaging data, like I said, we are now in the green room and we want to perform additional pseudonymization techniques, in this case defacing, where we remove those parts of the image. We use the tool that we have available in the VRE green room by first logging into the command line interface tool to enable our access for our assigned projects, and then retrieve our data inside the VM and run a singularity container, here VRE defacing, to run the processing step. If that is finished, we can take a look at the data and the results and see if the validation holds true and the defacing pipeline performed to our requirements. You can either just look at the plots that the pipeline created, use data visualizations for nifty images, and just interactively check our images and whether or not our requirements are met. If we are happy with the results, we push the data back into the green room storage and have it then available for the PI to copy that data into the core zone and make it available to all other project members that can use the data for further analysis. So once we have the data available in the core zone, we can again use the workbench tools to our disposal and now run additional processing steps, or if they are computationally expensive, just use the Charité IT high performance computing environment, using the seamless integration by just tunneling, using a secure shell standard procedure to access the computing node of those research environments and be able to harness the HPC power that is available. And we see the same data management tool, the VRE command line tool, is deployed inside the HPC environment, making it easy to move the data into results back into our core storage, where we then have all our process data available, our TVB ready data set that we want to use in further analysis for the virtual brain simulations using the virtual brain, which we will see in the next parts. That's for this part.
Thank you, Patrick. So we can continue with the next part, which is the brain simulation and TVB components in the architecture presented by Paula, I think.
Yes, hello everyone. Thank you, Pedro. So within the VRE platform, the virtual brain software is available for performing brain simulations mainly, but also for visually inspecting the pre-processing pipeline results. We will see that the virtual brain can be used in different ways, either directly from a command line or via a web user interface, and we offer these options in order to accommodate both types of users. Let us look at the relevant components for the virtual brain within this diagram. So the command line interface of the virtual brain can be used from the Jupyter Hub instance that is available in the VRE platform and represented through this component. And the web user interface is available at a public URL, but authentication for users is restricted to allow only users with valid VRE accounts. This interface communicates with the virtual brain backend server that is deployed inside one of the virtual machines available within the VRE platform. The data flow can be followed by these blue arrows. So within the core storage, data that has been previously processed by the pipelines can be easily accessed from both the Jupyter Hub instance and the TVB backend VM. Thus, the next step is for the users to start working with the data, import it into the virtual brain software, and perform simulations or explore it in different ways offered by the software. Now, let us look at a short demonstration of how these tools work inside the VRE platform. First, we log into the portal to see a short example of the virtual brain command line interface. Here we choose the Legion to TVB project to have access to the data, and from this page, we can start up the Jupyter Hub instance. Here, as you can see, I have the simulation ready data that Patrick has previously shown available. So the Connecton files and the T1 volumes are already here. And as a next step, we can create a Jupyter notebook and start setting up a simulation using the TVB command line interface. First, we will need to load the connectome from the data files we have just seen, then provide the necessary configurations for the simulation, and finally launch the simulation on this connectome. In order to continue with the Virtual Brain web user interface, we need to open a new tab in the browser. And as you can see, the web interface is now available at this public URL. Immediately, the software redirects us to the official login page of the VRE. So only users with valid VRE accounts can access the software. And after the login, we are taken back to the TVB landing page. I have prepared in advance a project called Legion to TVB, where I have imported the data from the core storage. So if we look at the data types available within this project, we can see the raw data representing the volumes that Patrick has prepared, and also the connectome. Based on this connectome, I've already launched the simulation, and we can see the results of that simulation are generated here as new data in TVB and can be visualized with different available visualization tools. For example, here we can see the resulting time series projected onto the T1 volume. The data produced by the virtual brain can be reused by other data exploration tools available in the platform. At this URL, we can access the REST API documentation that TVB provides, and the TVB provides this REST API in order to make communication with other tools in the platform possible. For example, this is what we use in order to integrate with the BrainCube software that will be later on shown by Pedro. And this being said, we now consider the virtual brain to be fully embedded into the VRE platform, being accessible at the public URL and integrated with the VRE authentication mechanism. It is compatible with data produced by the VRE pipelines, and at its turn produces data for other tools available in the VRE like BrainCube. And now I hand it over to Pedro to continue. Thank you.
Thank you, Paula, for your presentation. Yeah, so now I'm going to talk about the tool that we have integrated and used in the TVB Cloud platform for data visualization and exploration. This tool is called BrainCube. So this part of the diagram. And BrainCube is a neuroinformatic tool for exploration, analysis, modeling, and simulation of brain data that use interactive visualizations. This software requires high-end graphics and cannot be installed in a regular machine. So it is deployed actually in a physical server that meets the requirements of this software. So this is an example of the flexibility of the VRE infrastructure to accommodate also different needs for the different softwares that needs to run in this infrastructure. And basically, BrainCube integrates, let's say, it can access data that has been uploaded in the portal. So the data that has been ingested through the portal, then it's also available to BrainCube, following this part of the diagram. And as Paula said, also it's integrated with TVB through the TVB API, and this allows to access simulation services and to launch also simulations and analysis on the high performance computing resources. I'm going to move on to a little presentation also, or demonstration of the software. So also through the first step is go to the VRE portal, so where we can access the data that has been shared to my user. And from here, I can launch the access to a remote desktop in the browser, so I don't need to install any additional software to access. And on this remote desktop, I load the data from a patient that has been shared with me. This data is all processed in the remote machine, so it never leaves the premises, so it's always within this environment. So now I'm seeing the execution of the software in the cloud, and I can inspect, and I can start to inspect this data. No? For example, I can identify a lesion or define an area of interest. This is this white point or with cross that I am moving in the screen. And we have integrated a TVB knowledge base. So this is a method that has been developed by Charité that allow us to introduce some search terms and, for example, Alzheimer, and then we can show the areas of the brain where this term is more relevant. No? So the results that we see here is now we can interact with the data, and basically this method that we have integrated queries a database of 30 million publications in the Sky services provided by Fraunhofer Sky. And these maps are mapped back into the brain atlas. Yeah. So this method integrates information that also can be used as parameters in the simulation models and for specific disease. We can explore additional information, showing multiple source of data of multiple modalities like tracks, connectomes. So this helps to start to think on the brain dynamics and the brain models. Here we can also already connect using the TVB API to the simulation software. So we see the same information that Paula showed us before, but now in BrainCube. And from here, we can run analysis and we can launch operations. These operations will run in another machine, and if required, will run in the high performance computing facilities. And then you can inspect also back the results here, merging different visualizations. So for example, to show the results of signals analysis and brain dynamics. So at the end, in summary, BrainCube expands the access to the information required to data analysis, and it integrates different services like the high performance computing, the TVB simulation, the integration with the Sky services for data mining and exploration, different methods that also other partners have developed, like the TVB base, and it's a more friendly user interface for researchers and clinicians to explore the data. So at the end, it's summarized also the integration of a collective effort that we have done within several partners of the consortium in putting together this all these components in this software. So so that would be my presentation about BrainCube. So now I hand over to Moyes Dars from Indoc, who will do the final summary of the demo.
Thank you, Pedro, and I'm happy to provide some summary remarks and also some thoughts about what we're looking ahead to in the new year and beyond. So as we showed in the demo, the TVB Cloud platform and its various systems and components have been deployed and fully integrated within the virtual research environment, which provides this GDPR compliant data platform and environment. And the goal is to provide researchers with a seamless, effortless interface to get to the data and the tools that they need in order to perform their research, specifically around multi-scale brain simulation. And so what we've shown is that this integration, this deployment allows researchers to perform pseudonymization through the green room with the ability within that protected environment to isolate the data. There are capabilities for running processing pipelines in a containerized and standardized way and making use of high performance computing resources within the VRE workbench. There is the ability to standardize the data and to enable discoverability of the data through a knowledge graph system and through the use of various data models and ontologies, providing those standardized schemas. There are capabilities for running those simulations and also, very importantly, to be able to visualize the data pre and post simulation using the TVB web GUI and BrainCube that were shown, and that incorporates the semantic services that were developed at Fraunhofer through that integration with those front-end systems. And there are several other features within the VRE that also support the TVB Cloud workflows, and maybe we'll take a couple of minutes after this slide to walk through some of those. But I also wanted to mention that our large goal for the coming year, of course, is to complete this integration and to have a full production release of the TVB Cloud platform within the VRE environment. So some of the ongoing activities in that regard include the integration of TV Base, which Petra mentioned earlier, providing those brain region mapping services, which is also built on top of the SKY semantic services and molecular signaling pathway repository and knowledge base that Fraunhofer has been developing and that we're also integrating into the VRE. We're also excited about an open source release of the VRE itself, which will provide the community with the ability to actually look at the inner workings and the code, have access to the code that is actually powering the virtual research environment. So that's an upcoming goal in the new year as well to make that release. And finally, as Petra mentioned, the interoperability that is going to be built with eBrains through the Health Data Cloud is a very exciting development ahead. So just to dive a little bit deeper into some of these points, we can go to the next slide. And the first one, just to cover some of the additional features that the VRE is providing in support of the TVB Cloud workflow, we see here a slide mentioning provenance and lineage. And this is a very important aspect of any data management platform, to be able to capture what was done on data as it moves through its life cycle from data acquisition all the way to analysis and sharing and publication and so on. So we have those capabilities built into the VRE, and we're seeing a little screenshot of a lineage graph that is capturing the movement of data into the platform from the portal into the green room and through to the VRE core. And there are many such other operations that are also captured. As part of this capability, we mentioned DataLad, and DataLad is a critical tool being incorporated into the TVB Cloud through the Work Package 3, and we are working very closely with Michael Henke and team to integrate DataLad into the TVB, into the VRE backend in order to allow data to be better managed, providing reproducibility, standardized packaging, and the ability to make the data set and the processing portable across platforms. And the next slide then, an additional set of features, well, that's just the same slide, but also showing versioning capabilities in this screenshot that we've added here. The ability to capture different versions of the data, of course, is extremely important as the data sets evolve. So now on to the next slide. There are also built-in data set validation tools within the VRE and support for data models and schemas such as BIDS, the brain imaging data structure, which is a standard in the community to be able to capture both raw and derived neuroscience data from across different modalities. We also, of course, mentioned open minds earlier, and this is the ontology being used to annotate data sets and to provide discoverability of the data. These are also built into the VRE. For example, the ability to validate data sets that are encoded in these formats to ensure that we are complying with these standards that the community has developed. Next slide. We're also providing through the VRE information to the researcher to be able to understand how the VRE works, to be able to access all the necessary documentation, including some TVB Cloud specific information on how to run these tools that we've demonstrated earlier. And very importantly, there are policies and templates and documents available to researchers to ensure that their research is being conducted in a GDPR compliant manner within the VRE environment. And so data processing agreements, data sharing agreements, various other documents to support the researcher in completing their data protection impact assessments are being provided through the VRE Wiki. The next slide, please. This is just showing what Petra mentioned earlier, that there was a successful GDPR audit assessment that was done earlier this year. And this is what, in fact, enables this compliant processing of the data within the VRE. And on the final slide, I just wanted to also reiterate what Petra mentioned at the beginning, which is this exciting new development that we are going to undertake with a number of other partners in building the Health Data Cloud. And this is built on top of the basic baseline architecture of the virtual research environment supported by the TVB Cloud workflows. The TVB Cloud and the multi-scale brain simulation is a central use case of the Health Data Cloud. And we're now taking this architecture into a new era, if you like, and distributing this architecture, the ability to now share data across different nodes, the ability to integrate these data and to enable discoverability of data through the eBrain's central research infrastructure, the data gateway, the knowledge graph. And this is certainly going to benefit the TVB Cloud researchers that need to have access to additional data sets and to additional resources.